Alright, the next thing that we want to look at in this section is adding and subtracting rational expressions with unlike denominators. So let's go ahead and jump on into it. So before we get into rational expressions, let's just talk about fractions with unlike denominators. Let's say we want to add 1/6 plus 3/4. So if you recall, what we want to do is we want to start by finding an LCD. So our LCD for this is 12. 12 is divisible by 6 and it is divisible by 4. And so remember that this is something we need to multiply to. How do we get from 6 to 12? We multiply by 2. Whatever we do to the bottom, we do to the top, and we get 2 over 12. 3/4, in order to get from 4 to 12, we multiply by 3. And again, whatever we do to the bottom, we do to the top, and we get 9 over 12. From there, we go ahead and add our numerators. We get 11. We keep the denominator. This is going to be the basic principle that we want in order to add and subtract rational fractions. The only difference is that we're going to have variables involved. So let's go ahead and talk about our procedure. In order to add and subtract rational fractions with unlike denominators, the first thing we want to do is determine the LCD. The thing to keep in mind is remember that this is something we have to multiply to. So it's going to be at least as big as our denominators. We need to make sure that every denominator that we have is covered by the LCD. Our second step, we want to rewrite each fraction equivalently with the LCD. This is where we multiply top and bottom by the same thing so that we can go ahead and get a denominator equal to the LCD. We're going to add or subtract the tops. When working with rational expressions, when you are subtracting, remember that you want to distribute the negative. Since we're not going to be working with numbers, remember that our numerators might have more than one term, and so we might need to distribute. Finally, we want to simplify. We're going to factor the top and bottom, and we want to cancel common factors, just like we did when we talked about multiplying and dividing. All right, so let's go ahead and look at some examples. Example A, we have 6x squared, 7 over 6x squared plus 2 over 9x. So the first thing I want to know is what is my LCD? So let's start with the numbers. The LCD for 6 and 9 is 18. 18 is divisible by 6 and it is divisible by 9. And so now we want to know how many x's we need in our LCD. If I just put one x in my LCD, is that going to be enough for x squared? And the answer is no. And so when we talk LCD, recall when we talked about greatest common factor, we said you go with the smallest exponent. When we talk LCD, which is the exact opposite of greatest common factor, you want to go with the largest exponent. So if we look at 18x squared, we said 18 is divisible by 6, x squared. If I look at my x squared here, can I multiply to x squared here? Yes, they are the same. If I have 1x here, do I have at least 1x in my LCD? Yes, I do. And so this is going to be our LCD. All right, so now let's go ahead and see what we need to multiply by. How do we get from 6x squared to 18x squared? We need to multiply by 3. Whatever we do to the bottom, we do to the top. And so we end up with 21 over 18x squared. All right, what about our 9x? How do we get from 9 to 18? We are going to multiply by 2. And how do I get from x to x squared? We multiply by x. And so if I multiply this, I get 4x over 18x squared. From here we go ahead and combine the tops, and we can't really do anything except for combine it into one fraction. So we get 21 plus 4x over 18x squared. All right, can we simplify? There is nothing that factors out of the numerator, and so the answer is no. So this is our final answer. All right, let's try another one. Let's look at B. B, we have 3 over x plus 1 plus 5 over x minus 1. So for our LCD, remember that we want to think of these as being factors. X plus 1 is one whole thing, x minus 1 is one whole thing. And so our LCD on this one is going to be x plus 1 and x minus 1. Okay, so for the first fraction, we want to figure out what do we need to multiply by. Well, I have the x plus 1 in the first fraction. I am missing the x minus 1, so I'm going to multiply by x minus 1. In the second fraction, we have the x minus 1. I am missing x plus 1, so I want to multiply by x plus 1. From here, we want to go ahead and distribute to clear our parentheses so that we can combine our like terms. We get 3x minus 3 over x plus 1, x minus 1 plus 5x plus 5 over x plus 1, x minus 1. All right, so now we can go ahead and combine into a single fraction. And so I'm just going to go ahead and combine into a single fraction, and then I will go ahead and combine my like terms. If we combine our like terms, we get 3x and 5x combine to give us 8x. Negative 3 and 5 combine to give us plus 2. All over x plus 1, x minus 1. Now, technically, I can factor the numerator. I can pull out a 2, but is it going to simplify with the denominator? Am I going to get an x plus 1? And the answer is no. So if you want, you can factor, or you can go ahead and just leave it like this. All right, let's try a couple more examples. The first one we have is y plus 2 over 4y plus 16 minus 2 over y squared plus 4y. Okay, so before I find my LCD, I want to go ahead and factor so that we can see what we're working with. So for 4y plus 16, I can factor out a 4, and I am left with y plus 4. In y squared plus 4y, if I factor that, I can factor out a y, and I am left with y plus 4. All right, so now what is our LCD? Well, when I look at this, I see I've got a 4. I've got a y plus 4 that's repeated in both, and I've also got a y. So my LCD for this is going to be 4y and y plus 4. The y plus 4, I do not need to repeat it since it's one that appears in both factors or in both denominators. So this is my LCD. All right, so for the first fraction, what do we need to multiply by? Well, I have the 4, and I have the y plus 4. What I'm missing is y. So we are going to multiply the first fraction by y. So I get y times y plus 2 over, for my LCD, my 4y plus y plus 4 minus. Second fraction, what are we missing? We have the y. We have the y plus 4. What we are missing is the 4. So we're going to multiply this one by 4, and we get minus 2 times 4 over my LCD, my 4y times y plus 4. All right, so I'm going to go ahead and combine this into a single fraction. And I'm also going to go ahead and distribute. So in the first one, we get y squared plus 2y minus 2 times 4 is 8 over my LCD. Now, I do want to simplify this, and so I want to go ahead and try to factor it. So if we try factoring it, we get y squared breaks down to y and y. Things that multiply to 8, we get 4 and 2. And if we look at this, remember that in order to multiply to negative 8, we have different signs. I want my larger number to be positive. So this is going to be y plus 4 and y minus 2 over my LCD. Can I cancel anything? And the answer is yes, I can cancel y plus 4's. And what are we left with? We have y minus 2 left in the top, and on the bottom we have 4y. And we're good. All right, last example. We have 2y plus 1 over y squared minus 7y plus 6 minus y plus 3 over y squared minus 5y minus 6. So just like in the previous problem, the first thing that I want to do is factor the denominators. So if we look at the first one, this is going to factor to y and y. Things that multiply to 6 and combine to 7 is 1 and 6. And remember, to multiply to a positive 6, we have same signs. To combine to a negative 7, they have to both be negative. All right, for the y squared minus 5y minus 6, we factor that one as well. We get y and y. Things that multiply to 6 and subtract to 5 is going to be 1 and 6. We have different signs because we are multiplying to a negative 6. And my larger one is going to be negative. My smaller one is going to be positive. So now let's find our LCD. Our LCD, let's see here, we have a y minus 6 that is present in both. We have a y minus 1 in the first one, and we have a y plus 1 in the second one. So here is my LCD. All right, so now let's go ahead and figure this out. So the first fraction, what are we missing? We have the y minus 6, we have the y minus 1. We are missing the y plus 1. So I'm going to multiply 2y plus 1 times y plus 1 over. I'm just going to make this a little bit easier. I'm just going to write LCD for now. We'll bring it in a few minutes. All right, second one. We want to go ahead and multiply y plus 3. Let's see here. We have the y minus 6. We are missing the y minus 1. And we have the y plus 1. Again, this is going to be over the LCD. All right, so let's go ahead and FOIL first. If we FOIL, we get in the first fraction 2y squared plus 2y plus y plus 1 over the LCD. In the second one, we end up with firsts y squared, outsides is minus y, insides is 3y, and lasts is minus 3 over our LCD. We can go ahead and combine our like terms. We get 2y squared plus 3y plus 1 over the LCD minus y squared plus 2y minus 3 over the LCD for the second one. Okay, so now what I'm going to do is note that here we are subtracting. I want to go ahead and make sure that when I combine this, I distribute this to all of my terms. So when we combine, we get, I'm going to rewrite the first one, 2y squared plus 3y plus 1. And now I want to distribute my negative. So I get minus y squared minus 2y and minus negative 3 becomes plus 3. All right, we combine our like terms. I can combine 2y squared minus y squared gives me y squared. We have 3y minus 2y gives me plus y. We have 1 plus 3 gives me plus 4. At this point, I'm going to go ahead and bring back in my LCD. And what was our LCD? It was y minus 6, y minus 1, and y plus 1. The numerator, does it factor? The answer is no. And so we are done at this stage. All right, that takes care of adding and subtracting, unlike rational expressions, or rational expressions with unlike denominators. And so now you should be able to go ahead and do the homework. And I will see you with the next presentation.